Okay, so you can hit the front light, Jack, if you don't mind. Lesson 6.5, indirect proof. That's the type of proof that we're going to try to look at just for a couple minutes. Indirect proofs, we're going to look at that for a minute. Not too terrible. And then inequalities in one triangle. That is mostly what we're going to deal with today. The inequalities part and look at a couple properties of triangles. So I think you guys already know, like if you took a minute to think about them, you'd be able to figure it out and it would make sense, but we're just going to give some theorems to them. Our learning targets is to be able to first write indirect proofs. You'll be able to list sides and angles of triangles in order of their sides. And then we're looking at a theorem, triangle inequality theorem, to find possible side lengths. And these two sound like there's a lot going on, but they're not too bad. First, we're going to define what is an indirect proof. I mean, chapter 2 was all about proofs. And what do we do with chapter 2? We skipped it, yeah. So we didn't talk very much about proofs. In chapter 2, they would have introduced, I think, 3 or 4. I don't know if they get to the 4th one, but at least 3 different types of proofs. And this kind of would be an extension of those types of proofs. And so we're just going to give like an overview and talk a little bit about what these are supposed to look like, but you're not going to have to do crazy in-depth proofs. So an indirect proof. In an indirect proof, you start by making the temporary assumption that the desired conclusion is false. So let's say that I want to prove that, I don't know, well, let's go with this. Say I want to prove that I look like a golfer. I would start by assuming that I do not look like a golfer. So you kind of do a little switcheroo on them. You assume that whatever you're trying to prove is false. By then showing that this assumption leads to a logical impossibility, you prove the original statement to be true. So you have something that you want to prove. We are going to assume it's false. And then through a series of statements, we're going to show that the false statement that we said could never happen, that it's impossible. And that might sound a little bit tricky, but when we look at an example here, it won't be as bad as it sounds. Okay? So, if this was what they're asking us to prove, write an indirect proof that in a given triangle there can be at most one right angle. So they're saying prove that in any triangle there could only be one angle at the most, at the absolute most. I wrote down some notes for this one to get these out. So that is what we're trying to prove. Now, based on what we saw on the last slide, what would we want to assume to start out this proof? What would we want to assume? Yeah, Anastasia? Right. Well, you're on the right track. We want to assume, does anyone else have a guess? Can you say that one more time? That most do not have a right angle. You're on the right track. Any other ideas of what we could assume? That's okay. What they would be looking for us to assume is that there can be, oh, that's the eraser. There can be 2 right angles. Okay? That's what they would be looking for us to assume. They're saying that in a given triangle, there can be at most one right angle. That's what we are trying to prove. In an indirect proof, so when they give us that statement, there are different ways that we can look to try to prove it. The way that we are looking at today is called an indirect proof, and it just says that we assume that what they give us is not true. So to assume that it's not true, we would assume that there can be 2 right angles in a triangle. Okay, so if we have triangle, how this would look like a little more formally, if we have triangle ABC, that's what we're given. We need to prove that it can have at most one right angle. We're going to start out by saying, or by assuming that triangle ABC has 2
right angles. Okay? And let's just call these angles angle A and angle B. So if we have a triangle, ABC, we would start out this proof by assuming that it has two right angles. And we'll just say it's angle B and angle C are the two right angles. Now, kind of how proofs work in general, and I know we haven't spent a lot of time on this. If you're looking at this already and you're like, this is confusing, don't worry about it, okay? We're just kind of introducing it to you, and we won't take a whole lot of time on it. I see a lot of like faces that are like this, a little bit a lot of squinted eyes, but that's okay. If angle A and angle B are both right angles, what does that mean about angle A and angle B? They both are what? How many degrees? They're both 90 degrees, so angle A and angle B are congruent then, right? They're the same. So where we'd want to go next in this proof is to say by definition, angle A equals angle B, which equals 90 degrees. Okay? We start out, again, by stating the opposite here, stating that ABC has two right angles. Okay? And then because if we're going with this idea that it has two right angles, that means that angle A has to be the same as angle B. They both have to equal 90 degrees. The next place we would want to go I'm going to use some shorthand. So theorem 5.1. Who can find theorem 5.1? Someone, flip through your notes. Flip through your notes. 5.1. Tell me what it's called and tell me what it says. Chapter 5, yeah. Come on, 5.1. Oh, Anastasia. Yeah. What does that tell us? Right, that if we add all the interior angles of a triangle together, then you guys are doing something back there. What are we doing, Will? Alton? What's going on? No, you're looking at Will's iPad laughing at something. Theorem 1.5 tells us that the sum of the interior angles of a triangle equal 180 degrees. So if we go back to our triangle, angle A plus angle B plus angle C, all of these angles of our triangle added together has to give us 180 degrees. Correct? Right? We're familiar with that. Maybe that's a deep breath after we see that. Now we're going to substitute some things. So what did we say the measure of angle A has to be? 90. What about the measure of angle B? 90. We don't know what angle C would be. Based on this equation that we set up, what does angle C have to equal? 0. Now, is it possible in a triangle for the angle measure, one of the angle measures, to be 0? No, it is not. So hopefully you see, I know that this statement, an indirect proof, in an indirect proof, you start by making a temporary assumption that the desired conclusion is false. So our desired conclusion was to prove that ABC can have at most one right angle, okay? Alton, why don't you come sit right up here in front of Sawyer? Triangle ABC can have at most one right angle. So in our assumption, we assumed that a triangle has two right angles. Okay, so we assumed that the thing that we wanted to prove was false. By then showing this assumption leads to a logical impossibility, okay, so we worked through some things, used some definitions, used some theorems, and we found out that this idea of a triangle having two right angles could not happen, because that means that the third angle would be 0 degrees. So that would be the logical impossibility that they're talking about. You proved the original statement to be true. So since what we talked about here, what we assumed, since we proved it that it could not happen, in this type of proof, that means that what they gave us is actually true. Yeah. How do we feel? Really, how about this? I know that probably we could not do that on our own. At this point, I couldn't give you a proof and say, hey, go prove it. But when we are looking through here, do these steps and everything kind of make sense? What do you think, Kaylee? Kind of? Okay. That's all I'm going for right now. We'll worry about it a little bit more later. Let's move on to something that's a lot easier to understand. Theorem 6.9 and 6.10. The first one, triangle longer side theorem. If one side of a triangle is longer than the other side, then the angle opposite the Sid, not Sid. Should have put a picture of Sid the Sloth if I was going to do that. Side is larger than the angle opposite the shorter side. Okay? In other words, if we had to order, let's say that this was 11. In other words, if we had to order these angles from largest to smallest, angle B would be the largest angle because it is opposite of the largest side. Angle C would be the second largest angle because it is opposite of the second longest side. And angle A would be the smallest angle because it is opposite of the smallest side. So if you would rather write down this and not worry about the words, then that's okay. I'm not going to ask you to quote this theorem or anything. You're just going to have to know how it applies to triangles. Yeah. Yep. On the other hand, the larger the angle, okay, the larger the angle, the longer the side. So let's see, if this is 50 and that's 30, 80, this would be 100. Which side, if angle B is 100, which side would be our longest side? AC. What would be our second longest side? What would be our second longest side? Yep, because it is across from the second largest angle. And our smallest side would be a B. Okay? That's all that those two theorems are trying to get at. And that's what you're going to homework. Your homework's going to look more like this. Then you're not going to have to
another 30 seconds. Again, I would write down the theorem number, the name, and then the picture. I would not worry about writing down all these words because I think they overcomplicate it a little bit. So let's look at an example. Here's a real-life application that you can apply next time you go hiking. You are constructing the stage prop. Never mind. Next time you're gonna apply. That shows a large triangular mountain. The bottom edge of the mountain is 32 feet long. So the bottom edge, that seems like it would be here. The left slope is about 24. And the right slope is 26. List the angles of J, K, L in order from smallest to largest. So based on what we just talked about, what would be the smallest angle? What was that? Angle L would be the smallest because it is across from the smallest side. What would be the second smallest? J, because it is across from the second smallest side. So then the largest would be angle K. That's what your homework's like. You like that a lot better, I'm guessing. Yeah, that's a lot cooler. Now, on the other hand, list the sides of D, E, F in order from shortest to longest. First, we need to figure out what angle F is. So 51 plus 47 equals 98. 180 minus 98 equals 82. So this is 82 degrees. Then what would be our shortest side rated? That would look like that.
What?
Well. Okay, grow up and learn some words. What would be our shortest side rated? We look at these angles. Which one would be our shortest side? Yeah, it would. Yep, our smallest angle is 47, so our shortest side would be DF. What would be the next one? Hannah, can you help us out? What would be our next smallest side? FB, nice. And then Will, what would that leave us with for our longest side? BB. BB, perfect. Questions about that? We got one more example. Oh, one more theorem too. So this is the kind of second part of your homework. It's a little bit more difficult than the first part, but it's not anything too crazy. So theorem 611. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So let's say this is 12, 8, and 5. All that's saying is the sum of two sides of the triangle. Okay, pick any two sides. Maybe 8 and 12. It's going to be greater than the third side. 20 greater than 5? Sweet. Even if we choose the two shortest sides, that's the big one that's maybe a little bit more difficult to see. Even the two smallest sides of our triangle will be greater than that third side. That's it. Any two sides of the triangle we can add together to be greater than the third third side. So here's how this would be applied. The triangle has one side length of 14, another side length of 9. Describe the possible lengths of the third side. So let's say this third side is x, whatever that might be. Our third side could be 14 plus 9, and that would have to be greater than x, right? Two sides added together have to be greater than our third side. So at the largest, that third side could be, at the smallest, it could be just under, at the largest, it could be just under 20, right? It could be 22.9. Yeah. Yep. On the other hand, we could do x plus 9, that would be greater than 14, right? We add these two sides together. It would have to be greater than 14 on our third side. So our triangle has to be, or that third side has to be somewhere between 5 and 23. If you were to write that properly, it would look like this. Your nice inequalities you learn in algebra. So this is the most complex example that you'll see in homework today. One that looks just like this. So I can leave this one up on the board. But your practice is none. No class kick today. Go straight to big ideas. There are 20 problems. A lot of them look like these, and we'll go very quickly. And then there are probably a little less than half that look like this, where you will have to give like the range of what that third side of the triangle would be. So you've got about 45 minutes to get those problems taken care of. Once you finish, then you can work on other homework. No, go ahead. No, please go. Do you not trust me? Okay, thanks. Go ahead. Stop digging around. Alton. I hit you right in the backbone. That's not what I was going for. Going for the shoulder.
Okay. Big ideas. Once you finish,